Hello, everyone. This is Mr. Castillo. Hello, hello. And right now we're going to go over the notes for Monday, February 1st. So at this time, you should be on slide 48 of your digital notebook so we can get started. Okay? Once again, if you were absent and missed these notes, you can always go to Mr. Castillo's notebook. And then right here below, I'm going to put the link after I'm done with the recording so you can follow along. Okay? So let's get started. Slide 48. Now, for today, we're actually using the law, so Coulomb's law and the law of universal gravitation to solve problems. Now, a very quick note, the universal law of gravitation, we use gravitational fields. So those two are together. And for Coulomb's law, we actually use electromagnetic fields, electric and magnetic fields combined. So know that moving forward, Coulomb's law, we use electromagnetic fields, and the law of universal gravitation, we use gravitational fields. Just a good way to associate them together, okay? And then very quickly, when it comes to Coulomb's law, we use charges, and the charges are measured in coulombs, the unit for C. And then for the law of universal gravitation, we measure them in masses, and they're measured in kilograms, okay? So Coulomb's law of charges, coulomb, law of universal gravitation, masses, kilograms, okay? Just so we know the values for them, numerical values and the units for them, okay? And right here, I have the Coulomb constant and the gravitational constant, the actual values, which we'll talk about that moving forward. And then another one thing I want you guys to remember is the force of gravitation and the electrostatic force have the same unit. They have the same unit. And this is the first thing we're going to put on this box. The units we use to figure out the answer is Newton. Remember, newtons is a unit to use to measure force. And so we're going to use the same thing to find either Coulomb's law or the law of gravitation. So whatever value we get for the law of gravitation or for Coulomb's law, we are going to use newtons to basically signify what kind of unit it is, okay, the quantity of it. And then just know force of gravitation is the law of gravitation and electrostatic force is Coulomb's law. Just some vernacular and some words for that, okay? Now, let me move myself up. Oh, what happened? What happened? There you go. Can move maybe to the side, right here to this corner. Okay. Now, let's start with the notes. So there's four steps you're gonna follow when solving problems using the laws. Now, the first step is to read the problem and highlight key words. Okay, that's the very first thing you want to do is highlight keywords. Read the problem and highlight keywords. Okay, and words can be such as values, mass, repel, attract, charge, the actual question, electrostatic force, or the force of gravity. So words like that, you want to highlight them because they're going to help you moving on. Okay, that's the first step you want to do. The second step is identify if it's either Coulomb or the law of gravitation. So you have to remember which formula am I going to use. We know they're pretty similar to one another, but they also are very distinguished in itself, kind of like the do now you did for today. And for Coulomb, some characteristics, it could be if it says charge, you know they're talking about Coulomb's law. If they specifically say repel, you know they're also talking about Coulomb's law because electric and magnetic fields are the only fields that actually repel. And then another one I'm going to put right here is not only charge or repel, but electrostatic. So if it mentions electrostatic or electricity or magnetism, words like that, you will be using Coulomb's law, okay? Now for gravitation, it's a little bit simpler. If it talks about mass or if it talks about force of gravity, you know you're supposed to use the universal law of gravitation. And another one, if it talks about like planets or stars, you know, big, massive objects, or even people, or like things that are a little bit more macroscopic, you're going to use the law of gravitation. Okay, that's the second law. The second step. I'm sorry. The third step is write down the correct law formula. So now that you identified if it's either Coulomb's law or the law of universal gravitation, you have to actually write down the actual formula. So if it's Coulomb's law, I put it right here. It's right here, the Fe, the electrostatic force equals the Coulomb constant times the first charge times the second charge over the distance squared. So just know that this is the formula we use. And then for the universal law of gravitation, we use the gravitational force equals the gravitation constant times the first and second mass divided by the distance squared between both of them. So remember, they look kind of similar, but the differences, look at the differences, it's the constants and the objects. In this way, in Coulomb's law, we use charges, and in gravitation, we use masses. Okay, so just know those differences. So make sure you write down the correct law formula. And the fourth step and final step that we're going to do for now is plug in the values to the formula. So now you're going to plug in the actual values, right? So in this case, the electrostatic force, you're solving for this, so we know the units is newtons. And then Q1 and Q2, that's the charge of the object, and we're measuring this in coulombs. Remember we talked about that in the beginning, coulombs, which is that capital C, okay, coulombs. Then we have R, which is the distance between both objects measured in meters. And then we have the actual Coulomb constant, which is, this is the units right here, okay? And then if it's the universal law of gravitation, we use the the force of gravitation, which is solving for the units, which is newtons. Then we use M1 and M2, which is the mass of the object, and this one we measure in kilograms. Okay, measure in kilograms. Then we have the R, which is the distance between both objects measured in meters. And then finally, we have the gravitation constant, which is measured in these units right here. Okay, so just know you're going to be plugging in these values depending on what formula you use. So remember, 4 steps. Read the problem and highlight keywords. Identify if it's Coulomb or law of gravitation. Step 3, write down the correct law formula. And the final step for now, plug in the values to the formula. We're not solving the actual problem. We're not going to actually do the math. For now, we're just plugging in and then making sure the variables are in the correct sections. We're not solving for the problem yet. That's not yet. That's maybe until tomorrow, hopefully. Okay, so make sure you take notes of these right here. Make sure you copy down the blank text box into the correct section. And I'm actually going to bold this so you can actually see this much better. Okay, so pause right here and then copy them. Okay. Now, if you have copied them, now we're going to move on to slide 49 and actually do a problem. So if I move to slide 49, I'm actually going to do a problem, an example. So we're in slide 49, Monday, February 1st, visual example. The instruction says follow the steps and plug in the values to the correct place in the formula. And then I put right here in the yellow sticky note, I actually put the steps in case you need to, look at them for reference, okay? I have right here little circles that have first, second, third, and fourth step, and it has the setup for each problem as I'm going to be able to help you with it, okay? But just know that as we move along to the different problems, I'm going to take away one step, and so eventually you will be having to solve all 4 of these steps, okay? But for right now, I'm going to do this on my own so I can help you with it, okay? Okay, so the problem is, look at the first problem. The first problem is, suppose that 2 point charges, each with a charge of positive 1 Coulomb, are separated by a distance of 1 meter. Determine the magnitude of the electrical force of repulsion between them. Okay. Now, the first step was to read the problem and highlight keywords. So right here, as you can see, I did highlight keywords like charges, the magnitude of the electrical force, repulsion. I specifically highlight plus 1 Coulomb, a positive 1 Coulomb, and then a distance of 1 meter. So we actually have actual numbers right here. I'm going to identify them specifically as well. Okay, so I highlighted stuff right here. Okay. Oh, excuse me, I burped a little bit. So that's the first step. Okay. I don't think there's any more of these things we can highlight. So I think it's a pretty good place right here. So suppose that 2 point charges, each with a charge of positive 1 Coulomb, are separated by a distance of 1 meter. Determine the magnitude of the electrical force of repulsion between them. Okay. Second step. The second step is identify if we're going to use Coulomb's law or the law of universal gravitation. Well, I put right here a little description. I put the problem is talking about charges and about repulsion, which only magnetic and electric fields can do. Remember, the universal law, the gravitation fields can only do attraction. They only attract. But electric and magnetic fields, they attract and repel. So the fact that it says repulsion, we know it's talking about magnetic and electric fields. And if that's the case, then we know this problem is where we use Coulomb's law, because Coulomb's law uses electromagnetism, so electric or magnetic field. Okay. So that's step 2, identify what law it was. Step 3, I'll actually write down my formula. I just pasted a little formula for us because, like I said, it's just a little visual example. So here's my little formula right here. Okay, so we already got that. We wrote that down. The fourth step for now, and the fourth and final step for now, is plug in the values to the formula. Okay, so right here I have the values. As you can see, I color coordinated them, so you know which one we're talking about. Okay, so let's actually focus on this now. We have the electrostatic force, which is Coulomb's law, and then we know this right here is what K goes, the Coulomb constant. So if I go back to my notes, I can see right here that my Coulomb constant is 9 times 10 to the ninth power newtons times meter squared over Coulomb squared. So if I go down here, I can see that this is the one right here, 9 times 10 to the ninth power times newtons times meter squared per Coulomb squared. So I'm going to drag this over here. Okay. Now, these two that go out here on the numerator side, the top part is Q1 and Q2, the first charge and the second charge. Since we know that two charges with the same charge, positive 1, we know that both of these will go right here, positive 1 Coulomb and another positive 1 Coulomb. Fun fact, the reason it's repulsion is because it's a positive and a positive. And what happens when you get a positive and a positive? They repel. Remember, same charges repel, opposites attract. But since they have the same charge, they're going to repel. Hence why it says repulsion. Wow, right? And then the final part is r squared, which is the distance between both of those charges. And it says that they're separated by a distance of 1 meter. So I'm going to take my 1 meter right here. Now, it's not just 1 meter, it's r squared. So make sure when you put the distance on the denominator side, on the bottom of the formula, make sure you have a square. So I'm going to drag this 2, just so you know that you're actually squaring the value, okay? Because it's very important that you square it. If it's not squared, then the problem is going to be wrong, okay? So the answer is going to be wrong. So we just did this. We did the first step. We solved the problem. Suppose that 2-point charges right here. And then we highlight the words, right? We highlight the words and the key words. The second step, we identified if it's Coulomb's or the universal law of gravitation. In this case, we said there was Coulomb's law because it uses repulsion and charges. The third step is write down the formula, which in this case, I just pasted the formula right here. And then the fourth and final step for now is we just plug in the value. And that's how we're going to stop. We stop right there. We're not going to solve for it, at least not yet, until we get these steps in order. Okay? Now, your instructions for the Gaia practice today, slide 50, 51, and 52, is to basically do the same steps. But you see in slide 50, now I remove the formula, step 3. So now you have to drag step 3 formulas into the correct sections of the formula. Okay, the variables into the correct formula. Slide 51, I got rid of the second step. So now you have to tell me what the problem is talking about and which law are we going to be using. Okay, and then slide 52 for now, the last Gaia practice, the last practice problems, you're gonna do all of it. So you're gonna rate the problem, highlight it. Step 2, identify which law it is. Step 3, write down the formula by dragging the variables to the correct section. And then the final step for now is dragging the actual values, plugging in the values where the variables are. Okay, so that's what you're going to do. If you have any questions, you can always let me know. Obviously, if you're watching this video, you can't let me know because I'm not there right now, but you can always email me and contact me. Okay, so let's do that for right now. Okay, focus on those problems. And that's pretty much it. I'm going to pause myself now. Goodbye.